So, do you have any queries with regard to the previous session on system of equations? So, let us begin our today's session on system of equations one more time. So, we will do somewhat different models. What are the different models we can expect in the examination point of view? So, later we shift our discussion towards eigenvalues and eigenvectors, which are already known to you. Let us re-invoke the concept one more time, and we will do the what are the problem solving strategies available for them on eigenvalues and eigenvectors. So that will be our today's module. So first we go with the system of equations, the non-homogeneous case first, and then we go with the homogeneous case. Then we discuss about eigenvalues and eigenvectors. So initially we go with the problems, then we discuss about the theoretical parts. Clear? So shall we begin our today's session? So I hope that one assignment is posted in the Telegram group. You can check for the assignment on real analysis. So later I want to give one more thing, comprising the continuity part, limits part, and derivative part. So all the topics with regard to the real analysis are posted to you for your practice. So what are the questions you are having a doubt? You please give the question numbers to me. So within a convenient time, I will post the solutions for you, so you will get the full clarity how to solve a problem. That is the idea. Okay. In the middle, I will give. So later you can move with the previous year questions. So let us take the problem. Show that minus 2x plus y plus z equal to a, x minus 2y plus z equal to b, x plus y minus 2z equal to c has no solution if a plus b plus c is not equal to 0. So that was the question. Please take a note of that. Any queries to anyone? So do you want to add anything for today's session? Please tell. So I think you know how to solve this system. So let us write the equivalent form for the given system. So it is minus 2, 1, 1, 1 minus 2, 1, and 1, 1 minus 2, oblique A, B, C is the augmented matrix. So if we have written the given system in the matrix form, Ax equal to B, and you have considered the augmented matrix A by B, then this is equivalent to this one. So please check on that. So for computational convenience, in order to do the row operations conveniently, we can shift any of the two rows. Either you can shift R1, R2 or R1, R3. Suppose I have shifted the rows as R1 and R3 are interchanged. Then it was equivalent to 1, 1 minus 2, 1 minus 2, 1 minus 2, 1, 1 oblique C, B, A. So any kind of interchange we can do. Now, in order to get the echelon form, so we will apply the operations as R2 tends to R2 minus R1 and R3 tends to R3 plus 2R1. So it was equivalent to 1, 1 minus 2 oblique C, 0 minus 3, 3, B minus C, then you have 0. So R3 plus 2R1, so it will be 3, it will be minus 1, minus 3. Then you have A plus 2C. Again, to get the echelon form, we will do that R3 tends to R3 plus R2. So it was equivalence to 1, 1 minus 2 oblique C, 0 minus 3, 3, 0, 3, sorry, 0, 0, 0, B minus C, A plus B plus C. Agreed, all of you? Now what happened? In order to get the consistency for the system, either we should have rank of A must be equal to rank of A by B, which is equal to number of variables 3, or rank of A equal to rank of A by B, which must be less than 3. So then only we will have a solution. Now what happens in the augmented matrix? If A plus B plus C is not equal to 0, then we will get a situation that rank of A is not equal to rank of A by B. Rank of A will be 2 and rank of A by B will be 3. Agreed? So the system will be inconsistent. It means that it has no solution. So we have shown that for the given system, if A plus B plus C is not equal to 0, then it has no solution. Since how to find the solution or determine the solution is not at all asked, so we will stop our discussion at this moment. So we simply write that if A plus B plus C is equal to 0, then rank of A is equal to rank of A by B, which is less than number of variables. So the given system is inconsistent and it will possess a solution. So there we conclude our part. Okay. So if you are clear, let us go with the other problem. So can I take the other one? Please take a note of it. So can I erase? Okay. So the next question is, so let us consider the system as x plus y plus z equal to 1, x plus 2y plus 4z equal to lambda, x plus 4y plus 10z is equal to lambda square. Now, the objective of this question is we need to determine the values of lambda for which the system will possess a solution. Later, we need to determine what is the solution. So, by substituting the suitable value of lambda, we need to find the respective solution for the given system. So, the question will be asked as, for what values of lambda the system will possess a solution, and determine in the each case. That will be the question tag. Okay. For what values of lambda the system will possess a solution and determine in each case. Is the question tag clear? So let us begin with the solution. Let us write the augmented matrix. So 1, 1, 1, 1, 2, 4, 1, 4, 10, oblique 1, lambda, lambda square. Since the first row contains 1 in the first place, there is no need to do the interchanging of rows. So let us do the row operations as it is. So we will do that R2 tends to R2 minus R1 and R3 tends to R3 minus R1. Then it will be equivalent to 1, 1, 1, 1, 0, 1, 3, lambda minus 1, 0, 3, 9, lambda square minus 1. Again, in order to get the echelon form, we should make that this value should be 0. So we will apply the operation as R3 tends to R3 minus 3 R2. So it was equivalent to 1, 1, 1, 0, 1, 3, 0, 0, 0, oblique 1, lambda minus 1. And here you have, so you can say that R3 minus 3 R2, you will get the value as lambda square minus 3 lambda plus 2. So please check on that, whether I have written it correctly or not. So all of you agree for that? Fine. Now, since we need to determine the values of lambda so that the given system will possess a solution, since the last row has become 0 completely, in order to have a solution for the system, we should have the thing that rank of A must be equal to rank of A by B. It means that since rank of A is 2, we should have rank of A by B must be also equal to 2. So for this part must be equal to 0. If the value is not equal to 0, then rank of A and the augmented matrix both are unequal. So the system is inconsistent, it has no solution. So to determine the solution, we must say that lambda square minus 3 lambda plus 2 equal to 0. Now what happens if you factorize this one? It is nothing but lambda minus 1 into lambda minus 2 equal to 0, which gives that lambda is equal to 1 or lambda is equal to 2. Do you agree? So we have completed the first part of the question, that what are the values of lambda so that we will get a solution for the given system. So we have to take that either lambda is equal to 1 or lambda is equal to 2 to have a solution. Now to determine the solution, in this place we need to substitute the respective lambda values and we have to find the corresponding solution. So if you have substituted lambda is equal to 1, this system, because even though if you substitute lambda value here, by applying the row operations, you need to determine the echelon form, and from that only we are going to find a solution. So here, apart from taking the original matrix system, I am taking the reduced matrix system and I am substituting lambda value here so that it will give the computational convenience for us. So substituting lambda value there, you will have 1, 1, 1, 0, 1, 3, 0, 0, 0, oblique 1, 0, 0. Agreed? Because as and when you take lambda is equal to 1, that right side part will become 0. Now, how to find a solution? Do you have any idea for this? Anyone? Or I will give the formula. Any idea to anyone? So the thing here is, there is a formula that number of solutions, or you can call it as number of independent solutions, is equal to number of variables minus rank. This was the formula. You take a note of it. So here you will have 3 variables and the rank of the matrix is 2. So you will get one solution. It means that the number of independent solutions is equal to 1. So number of solutions means you consider that the number of independent solutions are nothing but 1. So while applying the echelon form, we always get an upper triangular matrix. You can understand that. Since we are determining the solution of the system by means of back substitution in general, so always we take that the last variable should be a constant, because in other words, how many free variables are there you are finding. In finding the number of solutions means how many free variables are there. So for this purpose, among the 3 variables, let us take that z is equal to k, a constant in the 3 variables x, y, z. Now from the final system, we are going to write the corresponding equations and we will determine the solution, how it is going to be. So from this system, you have the equations as x plus y plus z is equal to 1, this part, and y plus 3z is equal to 0. Since the last row is completely 0, there is no need to write any equation from this. You have taken that z is equal to k, a constant. So y plus 3k is equal to 0 implies y is equal to minus 3k. Substituting y and z values in the first equation, you have x minus 3k plus k is equal to 1 implies x is equal to 1 plus 2k. So the respective solution is x, y, z is equals to 1 plus 2k. Y value is minus 3k and z value is k. So you can write this vector form as k into 2 minus 3 1 plus the constant matrix or constant vector matrix is nothing but 1 0 0. So whatever the solution you determine for the system, it will be in this form. In other words, this type of notation we call it as a basis for the system, because the system will possess infinite number of solutions. By taking k is equal to different numbers, you are going to find all the solutions which are available for the given system, among which this is the independent solution 1 0 0 plus 2 minus 3 1. Okay. So any questions to anyone? Please tell. Please take a note of it. After noting, please inform. So anybody has any queries with regard to this? Right? Then I will take the second case in the problem. If lambda is equal to 1, then what happens? This is our system, right? Do you agree? Yes. So what is rank of A? This is 2. And what is rank of A by B? This is also 2. If you have written only A 1 1 1 0 1 3, this is A. If you have written A by B, it was like this. Its rank is also 2, because if you have say that rank of A by B is not equal to 2, it means that two rows must be completely zero in that, right? So is it clear now? Fine. So let us take the other case that so what happens if lambda is equal to 2? Please understand, you have determined the values of lambda by assuming that the system will possess a solution. It means that rank of A is equal to rank of A by B. From this assumption only, you have determined that lambda values are 1 and 2. Otherwise, you cannot find lambda values. On what prediction you are going to find the values of lambda? That's why, by assuming this, the solution will exist unless these two values are equal. You have determined the values of lambda, right? Now, for lambda is equal to 2, from the final matrix, you will have the reduced system as 0, 1, 3. This will be 1, 0, 0, 0, 0. So here also you have rank of A is equal to rank of A by B, which is less than number of variables. So you have the same formula is applicable here. Number of solutions equals to number of variables minus rank. So you will have one solution. So among the three variables, I am taking one variable as constant. So let us take that Z is equal to K, a constant. So again, write in the corresponding equations, x plus y plus z equal to 1 and y plus 3z is equal to 1. Since we have taken that z is equal to k, you have y plus 3k is equal to 1, implies y is equal to 1 minus 3k. So again, substituting y and z values in the first equation, you are going to get the value of x. So I will say that you will get the value of x as 2k. That you can check for that. Right? So you will get the values are x, y, z is equal to 2k, 1 minus 3k and k. So equals to k into 2 minus 3, 1 plus 0, 1, 0. So that was the solution part in the determination. Any more questions to anyone? Please check. I think the current question is given in the previous years. I hope so. This problem is given in the UPSC earlier. Please take a note of it. So x plus 2y plus z equal to 3, ay plus 5z equals to 10, and 2x plus 7y plus az equal to b. This was the given system. Now, the question is asked in two parts, that for what values of a the system will have unique solution. And the second part is asked as find the values of AB so that the system will have more than one solution. In other words, infinite number of solutions, we are finding that. It is nothing but solving the given system for what values of A, B it will possess a solution. In a simple line, we can understand the question tag as for what values of A and B we are going to get the system will have a solution or the system is consistent. So apart from this, the question will be specifically asked like this. What are the values of A so that you will have a unique solution? What are the values of A and B so that you will get more than one solution? Both are equivalent, right? In either of the way, the question will be asked. Is the question tag part clear to all? Right. So let us write the equivalent matrix system as it is. So 1, 2, 1. So 0, A, 5, 2, 7, A, oblique 3, 10, B. Now we are going to apply the respective row operations so that it will be reduced into echelon form. Since this part is already 0 below the first diagonal element, we should make that this one must be 0. So we apply the operation as R3 tends to R3 minus 2R1. So it will be equivalent to 1, 2, 1, 3, 0, A, 5, 10, 0. So this will be 3 and again A minus 2 and it will be B minus 6. Accepted? Right. Now again, to find a value or to reduce the system into echelon form, if you consider the second diagonal element, it must be equal to 0. So we have to perform the operation as R3 tends to. So A into R3 minus 3 into R2. Because in order to get 0, these two things must have the same coefficient. So you have to multiply this part with A and this part with 3. So I think you can perform the thing on your own. So it is going to be like this. Can you give me the values, what it will be? I will say it will be A square minus 2A minus 15. AR3 minus 3R2. And on the right hand side, you will have the part as AB minus 3A minus 30, minus 6A. Right. Is it visible to you clearly? So this part is A square minus 2A minus 15 and it was AB minus 6A minus 30. Now, from this point of view, we can say that in order to have a unique solution, what should be the criteria? We should have rank of A is equal to rank of A by B is equal to number of variables 3. This must be our criteria to have a unique solution. So it is possible whatever the value of B, we don't bother here. If this part is non-zero, then automatically we can say that rank of A by B, both will be equal to 3. Then you will have a unique solution. So if you have made this value as equal to 0, A square minus 2A minus 15 equal to 0, so you can factorize this. So what are the values of A then, if you factorize that? right? Both are positive or negative or alternative signs. So I will say you can have the thing as a plus 3 into a minus 5 equal to 0, right? So from this we can have a is equal to minus 3 and a is equal to 5. So we mentioned that if a is equal to minus 3 and a is equal to 5, then rank of a equal to rank of a by b, which is equal to 3. Hence, the given system will possess a unique solution. So in this module, we have completed part 1 of the question tag. Now let us go with part 2. So we need to find the corresponding values of AB here to have more than one solution. In other words, you will have the infinite number of solutions. So in order to have infinite number of solutions, we should have both values must be equal to 0. This must be equal to 0 as well as this must be equal to 0. So if we have made that AB minus 6a minus 30 equal to 0, you have already known two values of a. One value is minus 3, another value is 5. So if you substitute minus 3, what is the value of b? If you substitute 5, what is the value of b? So in this way, we have found the corresponding pairs of AB. So to have unique solution, rank of a by b must be equal to number of variables, 3. To have more than one solution, rank of a by b must be equal and less than number of variables. Yes, if a is not equal to minus 3 and a is not equal to 5, in such cases, determinant of a is not equal to 0, so that the three values are equal, hence you will have a unique solution, right? Please understand, rank of a is equal to 3 means determinant of a must be not equal to 0. It is possible only when this part is not equal to 0. That means that a square minus 2a minus 15 must not be equal to 0. So it will be equal to 0 if we have taken a is equal to minus 3 and a is equal to 5. So we violate these two values. So excluding a is equal to minus 3 and a is equal to 5, you will have unique solution for the given system. Okay? That was the idea. Right. So we should say that a must be not equal to minus 3, a must be not equal to 5 to have the unique solution. Right. So you substitute a is equal to minus 3 in that frame and give me what is the value of b. If a is equal to minus 3, what it could be? So minus 3 and minus 4 is the pair. If a is equal to minus 3 and b is equal to minus 4, then you will have the system frame will be like this. I will write the system so that you will have an idea. 1, 2, 1, 0, a is minus 3, 5, 0, 0, 0, oblique, 3, 10, 0. So in this way, rank of a by b both are equal and less than number of variables. So we will have more than one solution. Okay. So you substitute a is equal to 5 here and give me the corresponding value of b. 12. So 5 and 12 is one pair. Minus 3 minus 4 is one pair for AB, so that you will have more than one solution for the given system. So that was the conclusion of the problem. I think it was given earlier. So please check for that. Any questions to anyone? Say, or is the part clear? So please take a note of it. After noting, we will go with the other problems. Yes, because in the question it was asked that determine the values of AB. Solve the system in each case he didn't mention. So there is no need to find the solution separately. Whenever the question tag asked that determine the solution completely or determine in each case, then we need to evaluate the solution too. So based on the question tag, we will find the solution as per the requirement in the question. So for this problem, it is not necessary. So any other queries to anyone? Please tell. Okay. So let us take the other problems too. I am going to find other model. So give me a moment. So the complexity over this problem, we can expect that at the most you will have, say, 4x4 matrix. That could be our complexity in having the problem. That we can expect with regard to the examination point of view. So far we have discussed about the problems with regard to non-homogeneous system. So let us move with some of the problems based on homogeneous system, that is Ax equal to 0 concept. So may I know, do you have any other queries with regard to this non-homogeneous system? How to solve this? How to determine the values of A and B or lambda and mu to have the consistency, etc. So do you need any elaboration over this part? Right. So let us take with the homogeneous system case then. So the advantage of learning homogeneous system is, so solving this homogeneous system of equations is very useful while solving the problems based on eigenvalues and eigenvectors. So that could be our next topic. Because in finding eigenvectors, we will consider a homogeneous system and we solve them. So let us take one problem on the homogeneous system now, and we will do with the different issues on it. So this is our given homogeneous system. X plus y minus 2z plus 3w equal to 0. X minus 2y plus z minus w equal to 0. 4x plus y minus 5z plus 8w equal to 0. 5x minus 7y plus 2z minus w equal to 0. So this was the solution. I mean the problem. So we are going to find its solution. So let us write the equivalent matrix system, that is Ax equal to 0 for it. So it will be 1, 1, minus 2, 3, 1, minus 2, 1, minus 1, 4, 1, minus 5, 8, 5 minus 7 2 minus 1, and you will have the variable matrix x y z w, which is equals to 0 0 0 0. Okay, so since you know how to apply the row operations, I simply apply the row operations and I will write the final matrix. Is it agreeable to you? Say, or if you want me to write step by step, I will write step by step. Fine. So we do the operations as R2 tends to R2 minus R1, R3 tends to R3 minus 4R1, R4 tends to R4 minus 5R1. Then we will go for one more step, that R4 tends to 1 by 4 R4. Later we perform an operation that R3 tends to R3 minus R2, and then R4 tends to R4 minus R2. However, you can do the practice simultaneously in the problem. So you are going to get it as 1 1 minus 2 3 oblique and the second row will be nothing but 0 minus 3 3 minus 4. Please check for that. So after taking confirmation from your side, I will move ahead. So here the rank of the matrix is nothing but 2, which is less than the number of variables, which are nothing but 4. Now what happens? For the homogeneous system, you will have only 2 variables. Sorry, we have only 2 solutions. One is the trivial solution, nothing but all the variables must be equal to 0. Nothing but the 0 vector or the 0 column is nothing but the solution of the given system. The second one is non-trivial solution, which is nothing but always we will have a non-zero solution, nothing but infinite number of solutions we will get. So whenever you say that the rank of the matrix is equal to number of variables, the given system has only trivial solution, which is nothing but 0 0 0 0. As in when you substitute 0 only in the place of variables, the system will get satisfied. Non-zero solution or non-trivial solution means you are finding the infinite number of solutions depending upon a basis. How we are generating the infinite number of solutions based on a vector matrix, right? So here the number of independent solutions or number of solutions, the same formula we use, number of variables minus rank. It is nothing but 4 minus 2. 2 independent solutions or 2 free variables we will get. So among the 4 variables x, y, z, w, generally we take 2 variables as free, and obviously we take the last 2 variables as free variables. The general methodology. So let us take that z is equal to k1, a constant, and w is equal to k2, a constant. So from the reduced matrix, after doing row operations, you will have the part as minus 3y plus 3z minus 4w equal to 0. From this, minus 3y plus 3k1 minus 4k2 equal to 0 implies y is equal to 1 by minus 3 into 4k2 minus 3k1. Now we substitute x, y, z, w values in the first equation, that is x plus y minus 2z plus 3w equal to 0 implies x minus 1 by 3 into 4k2 minus 3k1 minus 2k1 plus 3k2 equal to 0. On solving this, you will have the value of x. So I think that you are going to get it as, so K1 minus 5 by 3 K2, I hope so. Because we will have the part as 3x minus 4k2 plus 3k1 minus 2k1 plus 3k2 equal to 0, plus 3x is equal to k2 minus k1 . Am I correct? Please check. So you are going to get x as please check for this. X is equal to 1 by 3 into k2 minus k1. Previous answer. K1 minus 5 by 3 k2, right? Yeah, right. I did. Yeah, right. Okay, I agree. Sorry. Yes, I agree with you. Thank you. K1 minus 5 by 3 k2. So the corresponding solution will be, so k1 minus 5 by 3 k2, then you can write it as so that was our solution. So after finding the solution in this pattern, there is no need to further simplify. Our intention here is nothing but what are the free variables and how you are determining the infinite number of solutions and what is the basis for it. So whatever the solution you consider, by choosing different values for k1 and k2, multiplying with those two columns, you will find all the infinite number of solutions for the given system. That was the whole idea. Okay, k1 minus 4 by 3 k2. That was the whole idea there. So you can choose k1 k2 as 1 1 1 0 0 1 minus 1 minus 1 minus 1 minus 2. In this, you can find the infinite number of solutions for the given system. That was the way in determining the homogeneous one. Is it okay? Any other queries from anybody? Fine. So the next one is So please tell me, are these problems interesting to you? Solving different models on the homogeneous system, right? If you feel bored, let us start the other topic. So here we are going to find the values of lambda so that the given system will have non-trivial solution, and if possible we are going to find what is the solution vector there. That means, since you are finding the infinite number of solutions for the homogeneous system, what is the basis for it? That is what we are doing actually. Okay, right? So the difference between the previous problem and this one is, earlier is just a homogeneous system. By simply applying the row operations, finding the independent solutions, you can solve it. Here one parameter is given, lambda, so that in order to have a non-trivial solution, what is the criteria we need to check here? In order to have a non-trivial solution for the homogeneous system, what is the criteria we need to check? If you have written the matrix form, let me say 3, 1 minus lambda, 4 minus 2 minus 3, 2 lambda, 4 lambda. So this is the equivalent matrix system for it. So what is the condition to be checked by us to have non-trivial solution? So we simply say that if determinant is not equal to 0, what is the rank of the matrix? Since it is a square matrix, we are not dealing with the rectangular matrix. Yes, always rank of the matrix must be less than number of variables. That is true to have a non-trivial solution. In other words, we can say that if determinant of A is equal to 0, then automatically you have achieved that R less than n. Rank of the matrix is less than number of variables. Because if I say that determinant of A equal to 0, then the rank will be either 1 or 2. So automatically it is less than number of variables 3. So you will have the non-trivial solution or infinite number of solutions. So let us make that the determinant of the matrix equal to 0. So let us make the det as equal to 0. So since you know how to expand the det, so simply expand the det. I am not writing it completely. So I will say that on the expansion, you are going to get the equation in lambda in the form as lambda square plus 8 lambda minus 9 equal to 0. So if we have factorized this, it will be, so which gives that lambda is equal to 1, lambda is equal to minus 9. That was the thing. So we have found what are the lambda values required so that the system will possess a non-trivial solution. So if you want to determine the solution in each case, we need to substitute the lambda values one after the other in the respective system, and we have to apply the row operations, and you need to solve the system. Okay. So let us take the case that lambda is equal to 1. So the system will become as 3, 1, minus 1, 4, minus 2, minus 3. Then you will have 2, 4, 1. The respective variables x1, x2, x3 equal to 0. Now you can apply the row operations, right? So let us apply the row operations as R2 tends to 3R2 minus 4R1, R3 tends to 3R3 minus 2R1. Why determinant would be 0 if R is less than n? If determinant is 0, then only rank will be less than number of variables, right? If determinant is not equal to 0, what could be the rank of the matrix? It will be 3. Okay. Yes or no? If determinant is not equal to 0, then the rank of the matrix is nothing but 3. Agreed? So it has only trivial solution, which is nothing but 0, 0, 0. We have taken the square matrix case here. Suppose we have taken the rectangular matrix, automatically the only checking condition for it is, after writing the homogeneous pattern, simply we check for row operations and we find the rank of the matrix. So in that case, we don't find a determinant. So if rank is R, number of variables are n, so n minus r independent solutions will be there. Based on that, we will take y1, z1, whatever the variables are there, we take them as constant and we will find the respective solution. Since we are dealing with square matrices only, the possibility is, if determinant is not equal to 0, rank of the matrix is 3, it has only trivial solution. If determinant is equal to 0, then rank will be less than 3, so you will have the infinite number of solutions possibility. Accepted? Any queries, please? That's what I am saying. If the matrix of order greater than 3, you have taken a rectangular case. Let me say, let's take a small issue like this. So here the number of variables are 3 and number of equations are more than 3. Accepted? It is a rectangular matrix. So in this case, we simply apply the row operations. We check for the condition for the rank. After reducing it into echelon form, we check for if rank is equal to number of variables, it has trivial solution. If rank is less than 3 number of variables, then we will take one variable as constant and solve the system. That's it. That we can try for it. Okay? But majority of the problems are based on square systems. So we are taking the square matrices case and respective problems on it. Rectangular system is simply applying row operation and finding the case. That's all. There will be no much difficulty in that. If you are good at applying row operations, then you have solved the system. That's all. If det equal to 0, then rank will be less than 3. Rank will be less than 3. Right. So if, that's why I have said, if det is equal to 0, rank is equal to 3. If det is not equal to 0, then rank will be less than 3. Sorry. Yeah. If det is equal to 0, rank will be less than 3. If det not equal to 0, then rank will be equal to 3. Clear? Yeah. Please take a note of that. So this is applicable for only the square matrices, not for the rectangular case. For the rectangular case, the only possibility is applying row operations, reducing it into echelon form, and check for the case. Rank, number of variables. So in that case, the checking conditions would be like this. We will write this. If rank is equal to n, trivial solution. If rank is greater than n, no solution. If rank is less than n minus r solutions, infinite case. This is the possibility for the rectangular system. Okay. For the rectangular system, that will be the checking case. Any other queries, please? Is it clear, or you need any elaboration on this? So please apply these row operations on this. And can you give me the matrix form there? After applying the row operations, how it will be? Now we apply the operation as R3 tends to R3 plus R2, and R2 tends to minus 1 by 5 R2. So it will be equivalent to 3, 1, minus 1, 0, 2, 1, 0, 0, 0. Accepted? So if you have written the corresponding equations, 3x plus y minus 3x1 plus x2 minus x3 equal to 0, 2x2 plus x3 equal to 0. So from this, taking the last variable x3 as a constant, you can say 2x2 plus k1 equal to 0 implies x2 is equal to minus 1 by 2 k1. Substituting the values here, 3x1 minus 1 by 2 k1 minus k1 equal to 0. Accepted all? So you can take the constant case separately. So if you want to write a particular vector, if you take k1 is equal to 2, then the corresponding solution will be 1, minus 1, 2. You can say that this is the basis vector. So whatever the solution you can consider for it, so every solution is nothing but a multiple of this that you can write. So since we have one more case remained there, that is by taking lambda is equal to minus 9, you will have the another system. You need to solve that. I think you can do it on your own. Can you? Is that required for you to solve? Please tell. We did one case that by taking lambda is equal to 1, we have solved. So we need to perform the other one, that by taking lambda is equal to minus 9, you will have another system like this, and you are going to solve it. Can you do? So please do it and give me the answer. Then we will discuss for one more problem. There we can wind up our discussion here on this system of equations. So that I have covered all possible models for it. I feel so. So can I erase this? You can do the problem on your own. right? So this is our next problem. Solve the system for non-zero solution. So if you look at the question tag, solve the first system for non-zero solution, it involves two things. One, you need to identify for what values of lambda so that you will have a non-zero solution, and you have to determine that solution completely. So two cases are involved here. Okay. So if you have written the equivalent matrix form here, so lambda 1 1 1 lambda 1 1 1 lambda of xyz equal to 0 0 0. So straight away, to have a non-zero solution, we mentioned that determinant of the matrix must be equal to 0 to have a non-zero solution. So here you can have two things that straight away you can find the determinant that is possible for you, or you can apply row operations, you can simplify that and you can find the determinant. So I think you know how to find the determinant. I will skip that part. I will write the equation as one minus lambda whole square into 2 plus lambda equal to 0. So which gives that the lambda values as 1 1 minus 2. So all of you can find the determinant, right? And you can find the lambda values too. Any doubts for anyone for finding the det? Say. Fine. Now in this system you are substituting the lambda values and you are finding the value. So if you substitute this 1 1 1 1 1 1 1 1 1 of xyz equal to 0 0 0. So by applying the row operations, R2 tends to R2 minus R1 and R3 tends to R3 minus R1, it will be converted in the form as 1 1 1 0 0 0 0 0 0 of xyz equal to 0 0 0. So here rank of the matrix is 1, which is less than number of variables. So the number of independent solutions are nothing but 3 minus 1, 2 solutions. So we are going to take two constants because we are having two independent solutions here. So you take that y is equal to k1, a constant, and z is equal to k2, another constant. So from the first equation you have x plus y plus z equal to 0. Substituting this, you will get x is equal to minus k1 minus k2. So the corresponding vector x, y, z is nothing but minus k1 minus k2, k1, k2, which gives that k1 into minus 1, 1, 0 plus k2 into minus 1, 0, 1. That was the solution for the given system, which is a non-zero solution. Accepted? Accepted all the solution part? If equal to 0 means what could be the rank? Less than 3. Accepted? Whenever rank less than 3, it means it is a non-zero solution, because we have found a solution here. Let me take k1 and k2 as 1 and 1. Then what will be the solution? Combining the two vectors, you will have a non-zero solution. Non-zero solution means apart from taking 0, 0, 0 in place of x, you can take some non-zero numbers so that the solution will exist. So if you take k1 is equal to 1 and k2 is equal to 0, the solution is -1, 1, 0. So x is equal to -1, y is equal to 1 and z is equal to 0. If you take k1 is equal to 0 and k2 is equal to 1, the solution is x equal to -1, y equal to 0 and z is equal to 1. These are the two solutions. Apart from this, you can take different values for it. So you can take k1 is equal to 2, k2 is equal to 4. You will have another solution. These are non-zero solutions. Agreed? Any more doubts? So have you solved similar kind of homogeneous problems at your study? Either BSc or BTech, whatever it is. Or you are learning for the first time? Okay. So can I take the other case for taking lambda is equal to -2? Okay. So if we have taken lambda is equal to -2, then it will be -2, 1, 1, 1, -2, 1, 1, 1, -2. So let us interchange the rows first for better application of the solution. Then you will say that R2 tends to R2 minus R1, R3 tends to R3 plus 2R1 will be equivalent to 1, 1, -2, 0, -3, 3, 0, R3 plus 2R1, 3, -3. So you have number of solutions is equal to 3 minus 2, 1 solution. So you take that, let z is equal to k, a constant. So you have the respective equations x plus y minus 2z equal to 0. Let me, yeah. And minus 3y plus 3z equal to 0. From this you can say that y is equal to k. Therefore x plus k plus 2k equal to 0 implies x is equal to minus 3k. So you have x, y, z is equals to minus 3k, k, k. Nothing but minus 3, 1, 1. Right. So we have changed R2 and R1 as interchanged, right? Apart from R1, R3. So in this way, we will find a solution for it. Any queries to anyone? Please tell. So we can say that these are the possible models on this homogeneous system. You can expect the complicated one as you can have a homogeneous system that the coefficients involved lot of parametric things. Let me say, suppose a problem is given as suppose the three equations are given like this. Now what happens while calculating the determinant, it will be somewhat difficult to evaluate for what values of k you are having the determinant as 0. So in such cases, we will say that the respective determinant will be evaluated by applying row operations. Apart from this, the rest of the problem is as usual. Finding the value of k, substituting it, and having the solution. That's it. So the only complicated part in this homogeneous system is having this type of coefficients in the matrix equation. That's it. So you have seen the problems with rectangular case. Square case, you have so many different questions, and this is one more possibility. So we can predict the different types of varieties or the homogeneous as well as non-homogeneous, in my opinion, in this module. Clear? So you can have a practice assignment I will give later. You can check for them. Any more doubts for anyone? Say. So if you are clear with this, then let us wind up our discussion here. And we will meet on Monday, taking problems on eigenvalues and eigenvectors. Is this concept sufficient for you in the problem solving strategies? Then thanks to all. We will meet on Monday.